Greetings and salutations. Thanks for watching this video. If you like it, be sure and click that thumbs up, okay? That tells YouTube that you liked it, and that means that other people might like it, so they show it to more people. I have found out that that's the way to get these videos advertised on YouTube, so thank you for doing that. And thank you to everybody who watched the last video I posted where we hung out for about an hour and played with VirtualBox. I had a lot of great comments on that video and more views than I expected, to tell you the truth, so thank you. One of the people who commented on that video asked about why they had to add themselves to the group VBox users when they installed the software. And I explained to them that it was about permissions. And that is one of the ways that Linux makes sure that you are working in a very secure environment, is using groups in conjunction with file permissions to make sure that only people who need it get access to whatever part of the system they have to be using without bothering other people or damaging the system or having the opportunity to put some sort of malware on the system. I thought it would be a good idea to do a video exclusively about this. Now, I have talked about this in past videos that were way more elaborate, where we walked through the entire bash terminal or whatever the deal was that we were doing at that time. But this time, let's just talk about these two concepts on their own. This is something that can mess up even advanced Linux users. I had a situation myself where I had a server that I made a boo-boo and I deleted everything in my home directory, all of it. And somehow or another, this screwed up the permissions on my account and it wouldn't work right. I couldn't do things. And so we noodled on this for quite some time, trying to recreate the correct permissions, and we couldn't do it. So we ended up actually nuking that account entirely and then creating a new one. It was the only way to fix it. So you can get way out in the weeds with this, and it can cause you a headache every now and again. But just keep in mind, it's one of the reasons that Linux is so secure on the desktop these days. Just a tiny bit of history before we jump into it, because it's always nice to know where this comes from. Linux is a Unix work-alike. Unix was developed by AT&T way back in the 1960s, and the idea behind Unix was to have a simple operating system that could be used to run huge computers. We're talking about computers that took up entire rooms at corporations and universities and government agencies. And these computers could have hundreds of users that would be able to get into them through terminals. You could have a terminal on your desk and you'd be hooked up by the network to the computer, which would be in another part of the building or in another state or whatever. Kind of sounds like cloud computing, doesn't it? Well, everything's a circle. So one of the things that the Unix developers were very concerned with was security from the get-go, making sure that data on the system could only be accessed by people who had a need to do it, that people couldn't do things to damage the system. So we have this concept of super users and file permissions that keeps the system safe. Fast forward to 1991, I myself was working at a big radio station where we had a Unix system. It was a system called Basis, and it ran on a mini-frame computer. And we had terminals all over the building, and the system administrator had given me an account, and I could log into this system and do all kinds of stuff with it. It was mainly word processing and bringing in news stories from news wires and stuff like that. Nothing too exciting. Linus Torvalds was working with a similar system that ran on Minix, and this was at the university he was going to in Finland. And he wanted to be able to have this system at home. I recall being kind of feeling the same way at the time. Like, oh, man, this would be kind of cool to run at home. And the sysop said, no, this isn't for home computers. It's for big computers. It's for big boy computers. You can't have this at home, you know. Well, Linus is a lot smarter than I am, so what he did was he went off and wrote the Linux kernel, which was the missing piece required to get the GNU operating system, which was a free and open version of Unix being developed by the Free Software Foundation in the United States, to work. So you took that Linux kernel, and then you took all the GNU tools, and you put it together, and boom, you had a free and open operating system. And here we are today. Thank you, Linus. Thank you, Free Software Foundation. So, as I said, this can be a little bit difficult to understand. What I want to do is walk through it one concept at a time. And the first thing that we need to do is create a new file. Now you see I've already been playing around with this because I removed this file, but we're going to recreate it. Let's go ahead and clear the screen starting from scratch. You didn't see that RM test there. It never happened. No. What we're going to do here is we're going to touch test. Touch is the command that creates a file. Oh boy. Now how do we know the file is there? Let's use stat. It's an old command. We're going to stat this file. I want to see what's in it. That's everything you could possibly ever want to know about a file using the stat command. We are mainly concerned with this line right here where it says access. This is where all of your permissions and ownership is shown. So let's walk through this real quick. This part would be the permissions for the file, and we're going to go through what all of that means in a moment. The UID, who owns this file? Who is the user? Well, it's user 1000, and that is Joe. That's me. The system, by the way, doesn't care what your username is. You can change your username all you want to. You can't change your user ID. That'll mess things up. And then we have the group ID. This is what group the file belongs to, and that would be 1000, which is Joe. When my account is created, a group is created called Joe. Now we're going to get into groups more later in the video. We've got to get through the file permissions part, and then we will see how they interlink with one another. So very cool. So a simpler way of getting this information without showing all this stuff, I just wanted to really, give you the whole overview here, is just to use the ls command with the long option, and it shows us the same stuff. We have the permissions over here. How many hard links are there to this file? Right there. And then we have who owns it? It's me. And what group it belongs to. And then we have, I think this is the last modified date here, isn't it? Now I've been trying to figure this out in my head. I'm pretty sure it's last modified, but instead of looking it up, why don't you tell me? Go in the comments and straighten me out on this, because it's either the creation date or the last modified date, and I can't remember. Then we got the file name right there. We also have up here what kind of file this is. It says it's a regular empty file. And if you're looking at a file, see, this won't tell you what kind of file it is. This added little hack here for you is you can use the file command. And we're going to do that on test. And it's going to tell me that file is an empty file. There's nothing in here. If this file contained a video, it would tell you. If it was audio, picture, whatever. Linux magically knows what's in these files and will tell you what they are. That's why we don't need file extensions. The system figures that out. Ain't that cool? Okay, so let's talk about reading permissions. Now we get to talk about the lovely ASCII art. Do you like that? I did that myself. So here we go. The first character in the permission string, and this is just a bunch of bits here set to different values. Okay? So the first one determines exactly what kind of file this is. Now there are three possible files that you can have here. Number one would be a regular file. That's just a block of data. It's an inode, which is how the file system that's on your block storage device figures out where files are. It creates an inode. When we use the stat command, that's exactly what we were looking at, was the inode for that file. That's all it was. All right. And a regular file just means it contains information. D means it's a directory. A directory is nothing more than a file that contains a list of other files. That's all it is. Way back a long time ago in the 70s and 80s, if you would have taken computer science classes or viewed any of the films from that era or read any of the books, they explained a directory this way. visualize it as a filing cabinet. And the drawer in a filing cabinet would be a block storage device. That would be a hard drive, or it would be a tape machine, or a floppy disk, or if you move it forward, CDs, DVDs, USB sticks, whatever. That's a block storage device. Just like with a filing cabinet, you can have a file which is directly put into that drawer. So you can have a file all on its own. Or you can have a file in a folder and you can put it on there. Or you can have an empty folder in there. Or you can have a folder that has files and other folders, and then those other folders have files, and it can go on forever and ever. That was the analogy that made us understand how directories work. So when they started doing desktops, Xerox and Apple working on that way back in the 70s and early 80s, they represented directories with file folders. That's where that came from. So today, directory and folder are interchangeable. I usually call it a directory because I'm very old school. A link file. That's nothing more than a file that points to other files. Now let's get into how the permissions are represented. And as you can see here, we have 3 possible permissions. It's read, write, and execute. R, W, and X. The first group after the part that denotes what kind of file it is the owner. In this case, it would be Joe, right? Why did you jump up like that? My mouse sometimes does that. It's a Logitech mouse, and I like it, but every now and again, for no reason, it does that. I touch it just the right way, and it jumps a page. Anyway, sorry. Focus, right. Okay, so the second group here would be the group ownership of the file. And the third would be other or the world. You can think of it as the world. That's anybody who comes upon this file on the system, finds it on a disk. What can they do with it? Now, I want to talk about the octal representation here, and that's right here. And we want to get down into this because this is the easiest way that my brain can deal with understanding permissions and setting them. There are other ways to do this, and we'll touch on that shortly. So when we're talking about octal values, think of a byte. A byte is 8 bits of information, right? And it uses the digits 0, 1, 2, 3, 4, 5, 6, and 7, 8 to represent things. That's how we're doing this. This is an octal byte. So in this case, read would equal 4, write would equal 2, and execute equals 1. So those can add up to different numbers here. So if we are read, write, and execute, that can be 7, represented in 1 byte of information. We're not going to worry about the 0 because 0 means nothing, even though it is one of the bits. In this case, it just represents no bits set. Now, ironically, to represent octal, 1 byte of information, you only need 3 bits to do that. Now, I've had people try to attempt to explain that to me mathematically in comments over the years because I have mentioned this concept before. I don't get it. For purposes of just an example and learning, I just want you to think of 0 through 7. Okay, that's it. So in this case, a value can be 0 through 7. That's all. So let's jump over here and play with our file, and we'll do some permission changes here. So as you can see, the way the permissions are set now, I'm the owner and I have full permissions. I can read and write this file, and then we have the group. Anybody who has access to the group Joe can read the file, and anybody who stumbles upon it can just read it as well. Well, what if I want to make this file completely mine? We would use the chmod command, and we would use 600. And what this is going to do is turn off all the permissions for everybody else but me. Oh. make it a little easier there, we'll just put it by itself. And as you can see from the first listing there and the one that I just did there, where, guess what? Now I'm the only person who has permissions to read and write in that file, and nobody else can do anything with it at all. So I'm being selfish that way. Let's talk about setting the execute bit. What does that do? The execute bit for a regular file basically tells the system that this contains code and that this file can be run as a program. So you could download a program file, for instance, like a script or a binary, and if you don't tell the system that it's executable, it won't run it. And you could also accidentally remove the executable permission from an existing program or script, and suddenly it won't run, and that's why. And this is one of another level of security. The system needs to know what is executable. You also have to remember that in Unix land, everything's a file and everything is plain text. So there's really no difference between each file. You could take your Rolodex database, for instance, your mailing list, and you could make it executable and the system would try and run it. And you can also take your word processor, the binary for that, and open it up in a text editor. Go ahead, have fun. You might be surprised what you see. So let's just set the executable on this for this particular file. I'm going to do it a little bit of a different way this time. We're going to go back over here, and we're going to talk about using letters to set permissions. Now, like I said, I don't particularly like doing this, all right, because for me it's confusing, especially when you start doing it at different levels. But for whatever reason, if you just want to set this thing to be executable, you can just do this. So we'll do, and we do plus, which means we're adding it, X, and the file is test. Alright, so let's list that again. You can now see we have set the executable bit at all permission levels. Now if you're in a hurry and you just want to set executable, that's the way to do it. But a file that is executable but not readable or writable is kind of weird, so I'm going to do it the old-fashioned way. Let's go back up here. And this time around, I'm going to show you another variation of this you'll see sometimes, especially if you are looking online for information about setting permissions. Sometimes you'll see a 0 in front, so now we have 4 instead of 3. And you're probably going, what's that? Well, that first one there sets a special attribute, usually set up by the system itself. It's not something that average users need to worry about, and it just has to do with executable permissions. Once again, who owns this file and who can do what with it. In our case, we really don't have to worry about it, but I'm going to put it there just because it exists and you might see it. So let's go ahead and change it now and see what happens. Okay, so now we're back to read, write, and execute. The standard permissions for a file that is executable would be something along the lines of something like that. Let's go through the process of making it an executable file just to drive home exactly how this works, okay? So I'm going to reset this back to 600, which means that the file now becomes something I can read and write, and that's it. Let's put some code in it. Let's do that. I'm going to use a hack here. If you've never seen this before, it's actually very cool. We're going to use the cat command, and we're going to take whatever I put into the cat command and redirect it into our file. So the first thing that we need to do is tell the system that this is executable. We'll use a shebang. Okay? And that's basically a hashtag or a pound sign. I call it a pound. And then you would put an exclamation point. This tells the system when you try and execute this, yes, this is an executable file. And the next thing that we want to tell it is what language it's in and where does it get the interpreter. In this case, we're using good old bash. So that's line 1. Now we need some code for it to execute. How about just that's an old standby for a first script, ain't it? Hello world. And we enter, and now we use the control key and D to tell cat that we're done giving it input. Now it should put it in that file. So we can cat that file to get it to print its contents on the screen. See, no text editor necessary. We created this all by ourselves. Now let's try and run it. Now, it's not in the path where we ordinarily put executable stuff on a Linux system, so we'll tell the system where it is, and we use that with the dot, which means the present directory, and then we're going to put this in here. Basically, we're saying execute this right here. This is what we're telling bash. So it says, nope, permission denied, ain't going to do it, not going to happen. We didn't set the executable bit. So let's go back up here and change this to a 7. That'll make it executable. And let's try this again. Actually, let's clear the screen before we do that. Now let's see if it runs. Bad interpreter. What did I do wrong? Okay, let's go back and fix what we did wrong here. That means I actually did something wrong. So let's cat the file. Oh, see? I made a mistake. You guys didn't tell me. Why didn't you tell me that? Jeez. Made me look like an idiot. Well, it happens to the best of us now, don't you? Doesn't it? Well, let's just go fix that right now, shall we? Me all confuzzled. Okay, we're going to do that one more time. And we're going to do and that's line 1. Line 2 is okay. And then Control D. And that looks like it'll actually work. So now the big reveal, will it run? Will it run? Yes, it actually did what it was supposed to do because the echo command doesn't do anything but type that on the screen. All that for that, I know. So that's the basics of permissions with files. Now let's talk about the execute bit with directories because that's a little bit different. It says when applying permissions to directories on Linux, the permission bits have different meanings than on regular files. The write bit allows the affected user to create, rename, or delete files within the directory. So that is the write, and modify the directory's attributes. And the read bit allows the affected user to list the files within the directory. Now think about that for a minute. Read means that you can see what's in the directory, and the execute bit allows the affected user to enter the directory and access files and directories inside. So if the execute bit is not set for you as a user, that means that you can see the directory, you can see what's in the directory, but you can't do nothing with it. So that is a level of security that you might want to play with. All right, now that we have had fun goofing around with permissions and you have a really good idea of how all that works, let's talk about how this works with groups. So on your Linux system, whatever you're running, I'm sure that there's a whole lot of groups. If you'd like to see the groups that you are a member of right now, all you have to do is type in the groups command. And you see that I am a member of a whole lot of groups. Okay? What does all this stuff do? Well, these are different groups that are made up on the system, and if other people are members of it, we could work together and we would have the same sort of access to a file. This was the original idea behind groups, because if you think about it, those big mainframes would have different departments that are working on things. And let's say the R&D department was working on some new product which was kind of super secret. They wouldn't want anybody else to be able to see it, but since everybody's using the same computer, they could have very strict permissions, and anybody who wasn't in the R&D group couldn't do that. So how do we change the group on a file, the ownership on a file? So that's actually really super easy to do. If it's a file that you own, then what we do is we use the change own command. So let's do this. Let's do change own, and actually let's try it and see if it works. I don't think that you can do this without being super user. In other words, you'd have to have sudo privileges, but I'm not sure. If it's a file you own, you might be able to do this. Let's just experiment and see what happens. So I'm going to change the file test to where it's owned by me, but I'm going to put it in the group vbox users. Did I spell that correct? Yes, I did. That's very important or it won't work, especially since we're trying something. I think it did it. Okay. So that means that if you own the file, you can do this. All right, so let's Yep, I changed the group ownership. That would mean that anybody on this system who is a member of the VBox users group could now see and work with this file. And of course, I own the file because I created it. So there's very much in Unix and Linux this concept of ownership. You own the file, and I'm going to let you use it by adding you to a group that I'm a member of, and if I don't want you to see that file anymore, then I can change that back to the way it was. So if I wanted to change it back to the way it was, then I would just simply use this. Right? So I've let you see that file, but now for whatever reason, I don't want you to see it anymore. And, well, hold on. Yep, that put me right back where I was supposed to be. So that's how groups and permissions work. So you could set up a system on your computer. Let's say that you had a computer that had several people working on it, all right? And you wanted to share a bunch of music files with everybody. You could create a space on that computer, a storage space, that was owned by all the users, or they had access to it, and then you could add them into a group called music, and then everybody would be able to contribute to that particular space on the computer. They would be able to add their own music files. Of course, they would be the owner, but everybody there could load those files and use them. To be quite honest, if we go to let's go to a directory on my system here. Let's go to Documents. All right. And I'm going to run. You're going to let me do this? For some reason or other, I hit the Tab key and it wouldn't do it. There we go. I wanted it to autofill and it did. All right, we're there. And this is my Documents directory. And I'm going to ls everything in here with the long attribute. Okay, so you see we have a whole bunch of files here that have different whatevers, and you'll see that depending on what system they are set up on, most anybody anywhere can read these files. Doesn't mean that they can change them, but they can read them. And then depending on other systems, there it goes. By the way, everybody always asked, wise parents drink. Let's talk about that for a second. It's a joke, y'all. A lot of these are jokes. I work in broadcasting, so there's all kinds of stuff in here. And there's another one in here called divorce settlement, and people go, "Oh my God, I'm so sorry you got a divorce." No, it's just a joke. People see that, but anyway, I hope I made my point there. So the permissions are actually a little bit loose. If you want to have files on your system that other users can't navigate to and see, that would be the way to do it. I guess that's about it. We've covered everything there is to know, except for giving a file to another user on the system. Now, in that case, that has to be done with administrator privileges. So I can make a file that is only owned by root and nobody else can use it. And this is important sometimes if, for instance, we wanted to put our little test file. Let's go ahead and do this. And let's see, have we been working? Let me see, where's test? Is it in here? Yes. So let's say that test, because it's executable now, we need to move it to another part of the system where it can be executed. Well, there's a couple of ways to do that. The first way to do it would be to simply copy it as root. Now what that's going to do is it's going to automatically change the permissions and the ownership on the file. Well, it won't change the permissions, but it'll change the ownership on the file to the person doing the copying. So let's say that we want this to be available to all of the other users. So where we're going to put this is we want to sudo cp. We're going to do test, right? And we want to copy this into the USR directory, Unix System Resources. That's what it stands for. Originally, it stood for user. Yeah. We're going to put it in local. And that means that this is the local machine. And we're going to do the bin directory there. This is where, on a Linux system, you stick scripts and binaries that you have created yourself that are not from the repositories or come from like deb files or RPM files for everybody to use. So it's going to ask for the permission to do that, and I'm going to give it permission. Right? So now if I go over here and I list this file, let's see what we get. No, just list it. And we just give it the direct path to it, which is going to be USR. We just put it there, man. Local and bin. And the file in there is test, right? So we want to ls that, and we want to do the long version of that so it would tell us what the deal is. So as you can see, it's now owned by root, and it's in the root group. So we had to do that because this is a system file. It could be owned by us. We could do it that way, but then the root user would have to make it ours. So for instance, let's do this. Let's navigate to that directory because it'll make it a little easier. All right, we're going to go over here, and we're in there now. And so what we want to do is we're going to do sudo, which means that we're going to execute this as the root user. We're going to do change own, right? And we're going to do the let's keep ownership of this, but we're going to put it in the group Joe. Now I have to do this as root. Okay, so let us ls that. And as you can see, it's in my group. So therefore now I, because I am a member of that group, will have executions, will have ownership privileges, but as you can see, I can't execute anything. I can't do anything with it, no matter what group I'm in. Well, I might be able to do that because I own it, but we can fix this. So what will we do to fix that? Well, we just need to change the privileges. And in this case, we'll have to do it as the root user. So we're going to do 755. and we're going to do test. Now it makes more sense. I can read and execute that. There you go. So I hope this helps to make this a little bit easier to understand. Permissions, especially for new Linux users and even for some people who have been using this system for quite some time, can really kind of mess people up. You know. Let's see. I'm going to delete this before I say goodbye. So we'll do sudo rm, and we're going to get rid of test because we don't need that at all. Bye-bye's test. And thank you for watching the video. Comments, suggestions, always welcome. And if you have anything to add, please be my guest. I don't consider myself to be an absolute expert on this. I'm just showing you my experience. Till the next time, see ya.